Now I am going to discuss about the assignment that's given on 24/8. In the assignment, first bit is state the select the correct statement. So first one, charge cannot be isolated. Charge and isolate chayana, which is first one. So not cannot another wrong one. So repulsion is the shoe test. There is in the monkey. Wax paper is the dielectric wire in the paper capacitor. Dielectric in the paper capacitor. Right one. Variable capacitor is used in tuning circuit. Is also correct one. So best choice is fourth option. So next one. A variable parallel plate capacitor and an electroscope. So in case of electroscope, reading is decreased by decreasing potential. The next third one. Three identical capacitors are connected together differently for the same voltage to every combination. The one that stores maximum energy is So you know U is equal to half C into V square. Here V is kept a constant. Here V is constant. So in order to make U as the maximum, so C is taken as the maximum value. Right? When C is the maximum, when the capacitors are connected in parallel, C is maximum. Right? Next, fourth one. The magnitude of electric field E in a angular region of the charged cylindrical capacitor is varies as. We know, in case of a cylindrical capacitor, the electric field is given as lambda by 2 pi epsilon naught r, right? Where r is the distance from the axis and it is varies inversely with the distance. So E is proportional to 1 by r. Next, fifth one. Two identical capacitors are joined in parallel, charged to the potential V, separated and then connected in series. The positive plate of one is connected to negative plate. Positive plate of one is connected to negative plate. So positive, negative, like they are connected in series, right? So the PD between these two terminals is V plus V. It is equal to 2V. And the next one, sixth one. A parallel plate capacitor is charged and is then isolated, recording the effect of increasing the plate pressure. So sixth one, parallel plate capacitor is charged and then isolated. Isolated means the charge is constant. Charge Q is equal to Q naught, taken as the Q naught, and it is the constant, right? And regarding the effect of increasing the plate separation, we know value of C in case of a parallel plate capacitor is epsilon naught A by D, right? So from this expression, it is clear that C and the plate separation both are inversely proportional to each other. With increasing the separation between the plates, C value decreases. C value decreases. So C decreases. Right? Now what happened to V? What happened to V? We know Q is equal to CV. QV is equal to CV. From this, V is equal to Q divided by C. With increasing the separation between the plates, value of C is decreased, so value of V is increased. Value of V is increased. So Q constant and value of potential increases and the energy is also increases. Use this formula. U is equal to Q square divided by 2C. Here Q is constant, it is Q naught square by C, and the value of C is decreased. So denominator decreases, so resultant one is increases. U is equal to Q naught square by 2C increases, right? So fourth option is the better choice. Next, which of the following statements are correct? When the capacitors are connected in parallel, the effective capacitance is less అన్నప్పుడు మనం దాన్ని తీసేయచ్చు. మోర్ అన్న కెపాసిటెన్స్ అన్ని ప్యారల్ గా కనెక్ట్ చేస్తే కెపాసిటెన్స్ ఎఫెక్టివ్ కెపాసిటెన్స్ వాల్యూ మోర్ అవుతుంది ఇప్పుడు కూడా. సో నెక్స్ట్ వన్, ది కెపాసిటెన్స్ ఆఫ్ ప్యారల్ ప్లేట్ కెపాసిటర్స్ కెన్ బి ఇంక్రీజ్డ్ బై డిక్రీజింగ్ ది సెపరేషన్ ప్లేట్స్, రైట్? నెక్స్ట్, when capacitors are connected in series, the effective capacitance is less than the least of the individual capacitance. It is also correct. Why? Because when the capacitors are connected in series, effective capacitance is 1 by C effective equal to 1 by C1 plus 1 by C2 plus 1 by C3, like that, right? Right. So next one, both B and C are correct. So next one, ninth one. A capacitor is charged by using a battery which is then disconnected. Dielectric slab is now slipped between the plates, which results. So what is about the ninth bit? In the ninth bit, a capacitor is charged by using a battery, which is then disconnected, right? Here, battery is disconnected. That means Q is constant. Q is constant. So Q is equal to Q naught to say it is constant, right? And the dielectric slab is introduced. What happened to the capacitance after introducing the dielectric slab? It is K times, right? So what happened to the V? V is equal to V naught divided by K. V is equal to V naught divided by K, right? What is about energy? Energy is equal to U naught by K. Energy is equal to U naught divided by K. So energy is equal to U naught divided by K. So what is the best option, right? So charge is kept constant, capacitance is K times, and the potential decreases, energy is also decreases. Next, 10th bit. Suppose n identical capacitors are joined in parallel and charged to potential V. In this manner, n capacitors are joined in parallel and charged to the potential V. Right? So cell potential is V, and given capacitors, each of capacitance is C, are connected in parallel. So we know in parallel combination, potential on each capacitance is the same, and which is equal to the potential of this cell. So indirectly given that potential on the cell is V. If the energy possessed by each capacitor is U, and the energy possessed by each capacitor is U, that is of V. Right. Now, then on joining them in series, now all these capacitors are connected in series. All these capacitors are connecting in series to the same battery, right? So we know in series combination, potential is divided, so it is taken as V by N, and it is V by N, and it is V by N, and so on, right? Say capacitors of each capacitance C. Then the energy and the potential difference for the combination is suppose these are the ends of the combination, V by N plus V by N plus and so on, V by N. So potential of the combination is V. Which is less than NV. Now what is about the energy of the combination? U dash is equal to half into C. Here N identical capacitors are connected in series, so effective capacitance is taken as C by N, and the net potential is V. So, but we know half CV square is equal to U, so it is equal to U divided by N, and which is also less than NU, Right. Next, 11th bit. A capacitor of capacitance 1 by 300 microfarad is connected to the battery of 300 volt and charged. Then the energy stored is, so we know U is equal to, basic formula is of CV square, that is equal to half into 1 by 300 micro 10 power minus 6, and the given potential is 300 volt. So 300 into 300. Right? So 300 into 50 microjoule. Right? Next, 12th bit. In the above question, energy supplied by the battery is. Suppose if U is equal to U is the energy stored in the capacitor, then the work done by the cell is taken as 2 times of energy. So it is equal to 2 into 150 microjoules. It is equal to 300 microjoules. Next, if an uncharged capacitor is charged by connecting it to a battery, then the amount of loss of heat energy is 13. Suppose the energy supplied by the battery is the QV, and the energy stored by the given capacitor is only half QV. The rest of energy supplied by the battery is wasted in the form of heat energy or light energy. So amount of energy lost is taken as W minus U, which is also equal to half into Q. Next, 14. two spheres of radii 12 and 16 have equal charge, right? So given that condition, note that condition, Q is constant. The ratio of their energies is respectively the ratio of their energies. We know U is equal to basic formula Q square divided by 2C, and given that Q is constant and 2 is also constant, so U is inversely proportional to C. So U1 divided by U2 is equal to C2 divided by C1. We know in case of a spherical capacitor, capacitance is only depends upon its radius. That means it is taken as R2 divided by R1, which is equal to 16 divided by 12, which is 4 side. Next, 15. Bit number 15. A condenser of capacity 10 microfarad is charged to the potential 500 volt. Its terminals are then connected to those of uncharged condenser of capacity 40 microfarad. The loss of energy. So in this case, the shortest form for loss of energy is of C1 C2 by C1 plus C2 into V1 minus V2 whole square. That is equal to half into C1 value is 10 micro into C2 value is 40 by 50 into 10 power minus 6 into V1 minus V2. It is 500 minus 0 is square. On simplification, we get 1 joule. Next, bit number 16. Energy is stored in a parallel plate capacitor C1, right? An identical uncharged capacitor C2 is connected to it, kept in contact with it for a while, and then disconnected. The energy stored in C2 is right. What is the common potential? So it is V common potential is taken as C1 V1 plus C2 V divided by C1 plus C2 is the common potential. And given that C1 and C2 both are one and the same, so common potential is V divided by 2. Say E2 is the energy stored in the second capacitor, which is initially uncharged. So E2 is taken as of C into Vc square. So on substituting it, we get it as E1 divided by 4, and given that E1 value is E. So final answer is E1 E by 4. 17. Two capacitors of capacitance 1 microfarad and C microfarad are connected in series, and the combination is charged to the potential difference of 120 volts, right? If the charge on the combination is 80 microcoulomb, then the energy stored in the capacitor C in microjoules is, right? So there are two capacitors, one is 1 microfarad and the other one is the C microfarad. First of all, find out the unknown capacitance of the given capacitor, right? So when they are connected in series, what you know, the effective value C effective is equal to C1 C2 by C1 plus C2, and given that C1 value is 1 and C2 value is C, right? So it is the effective value of C, and given that Q net is taken as C effective and the given potential V, given that it is 80 is equal to C effective is C divided by C plus 1 into given potential is 120. So it is 2 times and here 3 times. 2C plus 2 is equal to 3C and C is equal to 2 microfarad. So value of C 2 microfarad and వచ్చేస్తుంది. Now I want to calculate the energy stored in this one. Energy stored. Use the basic formula. U is equal to Q square divided by 2C. So it is equal to 80 into 10 power minus 12 divided by 2 into 2 into 10 power minus, right? So it is 1600 into 10 power minus 6 joule. Next bit. A parallel capacitor, I think it is 16th bit, right? Next bit, a parallel capacitor of capacitance C is charged and disconnected from the battery. The energy stored in is E. If the dielectric slab of the constant 6 is inserted between the plates of the parallel plate capacitor, the capacitance will be. When a dielectric slab of dielectric constant K is inserted between the plates, the effective capacitance becomes C is taken as the Kc naught, right? So it is equal to 6 C naught. What happened to the energy in this case? In this case, the battery is disconnected. Battery is disconnected. So in this case, the energy stored in it is taken as U naught divided by K. So it is U naught divided by 6. So here U is taken as E, right? So it is E by 6. So next problem, problem number 18. A capacitor is filled with an insulator and a certain potential difference is applied to it. The energy stored in the capacitor is U. Energy stored in the capacitor is U. Now, the capacitor is disconnected from the source and the insulator is pulled out from the capacitor. The work done is. So, expression for the work done in this case is half CV square into K minus 1 is the shortcut formula. And given that it is 4 times of U, and we know half C is also U, it is equal to K minus 1. U get cancelled. So 5 is equal to K. And the last bit in the assignment, here two capacitors are in parallel. Two capacitors are in parallel, and given that the area of the plate is 50 cm square and the separation between the plates is 3 millimeter. The energy stored in this combination is, first find out the effective combination. It is 2 times of C. It is 2 times of epsilon naught A divided by D, right? So first of all, find its value and then substitute the expression. U is equal to half C effective into V square is the basic formula. So it is equal to half 2 times of epsilon naught A divided by D into, given that V is 12 volt. 12 volt. So both are cancelled out. We know it is 8.85 into 10 to the power of minus 12, and the area of the plate is 50 cm square. 50 into 10 power minus 4 by separation between the plates is 3 millimeter. 3 into 10 power minus 3 into 12 square is 144. Right? 144. So final on simplification we get its value is 2.1 into 10 to the power of minus 9 joule. 2.1 into 10 to the power of minus 9 joule. Right? Okay, Nana? Okay, bye.